Good morning, everyone. The topic of the discussion is basically the continuation of three presentations that we've seen today. So before I go ahead with the topic at hand, since this is an active discussion at IETF, I would like to acknowledge the participation of various vendors and operators for the work that we see today. So there was lots of work at IETF. It's a very active discussion, and with the work of all these operators and vendors, we are try to achieve whatever I'm showing here. So when we talk about IP over DWDM, or packet over optical, or packet optical integration, various names for the same topic. So assume that I have an IP network. I have two routers, a representation of that. I have an IP link in between. From the router perspective, they don't have any idea how these two are connected together. In reality, I have an underlay which is connecting routers together. The router on the left-hand side is connected to a transponder, a transceiver, which basically does the modulation. This one goes to a photonic line system. Basically, everything becomes the analog, becomes the color, becomes light, routed through the network, and on the side, we do the reverse. At the end, we are creating one or multiple layer 0 photonic system or photonic services, which basically maps that IP link to to the L0 services. This mapping could be one-to-one, one-to-many, or many-to-one. But at the end of the day, when you are looking at the topology of the IP network, think about this layer 0 service or services which is underlay for that the system. So if we extend this concept and we go and we go to same picture, now take the transponder and the gray optics with today's technology, shrink it, and put it inside the router. Now we have a device inside the router, which basically we call it pluggables, plug, coherent pluggables, all these different names for the same concept. The important concept here is, from the IP perspective, router doesn't understand or doesn't know any of this. From the IP connectivity between router 1 and router 2, the concept is exactly the same. And the whole idea, the art of the creation of that network here is how we can create these layer 0 services, if it is needed, what is needed, how many of them are needed, and bring that one to the IP. The one thing which is also very important to consider here, layer 0 services versus layer 2.5 and 3 IP MPLS services. The life cycle of the IP MPLS services is very dynamic. Dynamicity is the nature of the game. You can create or delete any layer 2, layer 3 services at any time. You can modify it. This is not the case for the layer 0 services. Layer 0 services by nature are topology of the network. How often you go and change the topology and remove a router or add a link to it. So it is very important to consider the life cycle of a layer 0 services versus other services as we go through that. I'm extending this network that I started with. Now I'm adding 2 more routers to the picture that we have before. Now, in this case, router 1 and 2 are connected through the transponder and the ROADM system, whereas router 3 and 4 are connected through the pluggables. The important aspect, again, in this picture is there are 2 routers, 2 IP links, and these routers are not aware of any of those. But the important aspect here is, as we go through the brownfield networks, we have to consider combination of all these together. I have a network of the routers, transponder, muxponder, pluggables, and the photonic system, including ROADMs and everything. It is very important to consider that this is the heterogeneous network that we are dealing with. And as we go through the control and management through the perspective of a controller sitting on top of the network, we have to consider that at the end of the day, regardless of how we are implementing IP and optical controls, the network for the full automation should consider all of this together. We cannot exclude that. And this is very important aspect to consider. If I have a greenfield only pluggables, my control is completely different from a heterogeneous network that it has mix of everything. For foreseeable future, this is the reality of the network, and we have to consider, and at the end of the day, we should design an IP system as we go through it, IP control, optical control system, which basically address any combination of whatever we want to do. And this is the important aspect to consider. So now I know what the pluggable is. I know that I have a host, in this case router. There are two sides of the pluggable. One side is photonic optical characteristic of that. In most cases, host or router is not aware of the characteristic of that layer. What is the modulation? What is the bit rate? What's the baud rate? What is the dispersion? Or all those things is relatively not important for router. I can say relatively, and this is the active discussion that we have on IETF, it might be some scenario that some of the attributes needed. But in most cases, this attribute is not relevant for the router. Whereas the other part, which is the electrical side, the part which is host side, we are connecting it to the router or host in this case, are characteristics that should be the same on the host side and pluggable. And this is important to consider these two aspects, and as I go through the presentation, you will see how it differs. If you are familiar with OIF, CMIS, these two aspects is called media ID and host ID. I just mentioned this one because for those people who are a bit familiar with that, they can map that one to this mindset. So adding additional layer to the discussion is the multi-layer. Now I have an IP network, I have optical network. By the nature is multi-layer. When I have this multi-layer, multi-vendor network, it basically create a relationship between layer 0 all the way to layer 2.5 and 3 IP MPLS network. We have to make sure that we have a correlation between underlay and overlay. Again, as we go through the presentation, you will see it, regardless of how you want to implement it, these are the things that should be covered with the full automation in mind. And the important aspect of this one here is the multi-layer will be some part of the discussion as we go through it. And you will see how it manifests itself as we go through the presentation. From the perspective of the use cases that we have for the multi-layer, because this is one of the aspects, again, these are some of the aspects which complements the three presentations that we see in the morning here. So Sienna defines 5 type of the category of the multi-layer benefit for the operational characteristic of IP over DWDM. And all this, as you see, some of these are basically repetition of the previous discussion that we have this morning. But the important aspect of this one is category 5, which is the discussion today. Life cycle management of the pluggables. I have a pluggable, I have to detect it, I have to inventorize it, bring it to the ecosystem of the controllers, and after that, do everything that I am able to do with the normal transponder. I have to be able to do it. Creation of service, modification, monitoring, and so forth, and we go through that one. And as I mentioned, Sienna defines various use cases, very concrete use cases for each of these categories. If you are interested to see what are those categories, please see me at the end of this presentation. We can go through it together. So now let's go back to pluggables and management and the activity that we have at IETF. One important aspect that we have to consider when we talk about pluggables and control, that layer control could be any IP optical or any higher layer controller. The way that pluggables receive information or transfer information to the outside world from the control perspective is through the northbound interface of the router. This is the view that we have today, and this is the way that we are working, because it is important to understand as we go through the presentation, where is the source of the data coming from? So internally, router talks to the plug, get the information, convey the information to the plug, depends on its configuration or telemetry, and through the northbound interface, this will be exposed to the outside controllers. Now, let's go to one router. As you see here, these boxes that I show here are the functional boxes. I have vendor, the host is from vendor Z. I have two pluggables, one from vendor Z and one from the vendor Y, one vendor X. Basically, here it shows the multi-vendor aspect of that. The whole idea here is how I can expose all the characteristics of these pluggables to the outside of the routers. I have the pluggables characteristic, photonic optical from one side, host and electrical from the other side, and how I can expose it outside. So basically, this is the first part of the activity that we do at IETF. Basically, we're defining how all these characteristics should be exposed to the external system. So if I go one step further, now I have the model at the northbound of the router. I'm modeling the photonic, optical, and host side of the pluggables. If we want to do internal translation of that to the pluggables, if you're familiar with OIF CMIS, this is the protocol that basically sits here. Sometimes I feel that there might be some confusion between where the CMIS is and the IETF is. Basically, CMIS or OIF talks about internal dynamic of the router, whereas IETF is taking a look at everything as a network-wide. We take a look at the network and how everything will be exposed. They are related to each other, but the activity that we have, the first one, this one is the current activity at IETF. This one is something that we put as a phase 2. So this is not the context of the first activity at IETF. So now I have the pluggables. I just go inside the pluggables. We define 5 blocks, as you see, coherent optical one side, electrical on the other side. Then the whole idea for us is to go through various the modeling that we have and try to characterize that. The important aspect that we started with, we didn't only focus on the IETF. We wanted to be not reinventing the wheel, try to go through all different standards that exist today, IETF, OpenConfig, TAPI, OIF, ITUT, and others, to see if we want to model both sides, how it's going to work. And this is a very important aspect, again, to consider that we want to make sure that we want to be practical. We don't want to spend too much time on something that is already there. If there is something there and we can work and we can use it, we want to do it. And this is the important aspect to consider, and this is something that it really resonates with everybody at IETF, from vendor side or operator side. We want to be practical because we know the time is essence, and it's important to consider something that is workable and might be 80, 90% workable is good enough. We want to do something that is really tangible in near future. And the important aspect, the item 2 and 3 that you will see here, other aspects related to CMIS OIF integration. We think that is a very important aspect. This is something that generally is not discussed. We are looking at the IETF or OIF, depends on who you talk to, but it's important for a quote-unquote plug and play. When you want to put a plug of vendor X to the router Y and you expect everything works, that aspect also is very important to consider. And the other aspect, there are next step. This is one activity from the vendor side. The parallel activity from the operator side is also happening at IETF. Now, operators take a look at the system as a network and define the use cases for the topology and use cases for the various activity that we want to do. And again, this is very important activity because this is the backbone of whatever modeling we want to do. We want to do something, and because of that, we want to make sure that we can cover that. So There are various use cases. These use cases are covered from the very basic discovery and inventorizing the pluggables, discovery of layer 0 service and so forth, to creation of the services, and after that creation of the IP MPLS service on top of that. So this is the second activity that happening at IETF. Both are going very well together. Now a step up towards the controller. And we see a flavor of this picture today at least 4 or 5 times. It is very important to consider, I put the controller in a cloud, and there is a meaning for that, and the meaning is shown here. The boxes that you see here are functional boxes. We are not saying that there is one box called IP controller, one box is optical and so on. We say that there are functional activity for IP, optical, and the multi-layer needed. And it is a very important concept because it is a simple concept, but sometimes if we show this picture without any context, people think that we are talking about 3 different controllers, and they say, which controller is what? Here is the functional boxes. We need a functional box to address plug-to-plug manageability and life cycle, regardless of where it resides. And from that aspect, there are 3 different use cases that we have to address. IP only, photonic optical only, or multi-layer. And again, you will see multi-layer is showing up here because this is one of the use cases that at the end of the day connect this together. I put 2 realization of the SDN controller to just make sure that we talk here about something that for the previous picture, it is really valid to realize it with this dotted line. Now, these dotted line are the physical boxes. You can do it whatever you want. There is a mix and match of whatever is needed, and this is important to understand the concept of the controller from functional perspective versus the realization of that. So the next topic that I'm referring, as you will see here, this is something that we put on hold at IETF. I put it here just for the completeness, but I wanted to make sure that you are aware that we go through this activity after finishing the first 2 activities from vendor side and operator side. I just put it here to make sure that we are completing the discussion. This is our food for thought, going forward. So if somebody asked me about the controller, again, you see the flavor of this picture today as well. From the controller perspective, and the acronym that you see here, PNC and MDSC, this is the acronym that the IETF ACTN uses for the controller and for the higher layer orchestration, just for the completeness of a discussion. You will see here there's IP network, photonic network, optical network. The first option that this draft that you will see here is describing is how I can put the characteristic of optical pluggables into the optical controller is through the read-only channel. It could be the option 2, which is doing the read-only. Exactly as you see here, there is completely separation, segregation of IP and optical. And there is another draft. They say, can we mix and match of that one? Can I have the controller read-write to the plug through the routers? And this is important to us consider. This is just 3 options. This could be option 4, 5, 6 in the future as well. This is just an option. Whether or not we want to go with that, this is up to us. This is work in progress, and it is important to consider this is we are designing it as we go at IETF. So if I summarize it, what is the takeaway for today's discussion? The first one is the packet over optical integration, aka IP over DWM, is active discussion on IETF. The goal here is to try to do plug and play from the pluggable perspective, and there are lots of activity happening. We want to mix IP, IETF and OIF and other SDOs together. So there is a strong operator-driven use cases. There are a strong collaboration. As you've seen, all the things that we mentioned here is the collaboration of a group of people from vendors and operators. And last but not least, this is important to consider. The overall goal is the full life cycle management of the pluggables and the IP over DWM, whether or not there is a pluggable in the network or not. Thank you for your attention.
Thank you very much.